Minute Math. When you need help, you use Minute Math.
I'm Sean Gannon, and this is Minute Math. And today we're going to learn about evaluating functions, and we're going to evaluate this function. So, here's our function. H of t is equal to the absolute value of t plus 2 and absolute value plus 3. We want to find h of 6. Okay, so given our function that's right here, we want to find our h of 6. H of 6, meaning wherever t is, we need to put a 6. So we have h of 6 right there, represented like that, is equal to the absolute value. Let's plug 6 in for every single t. So t is 6 right there, plus 2. Absolute value is brought down still, all right, and then plus 3. So now we have absolute value 6 plus 2, and then plus 3 on the outside. Well, what we have now is the absolute value. We can solve within that first. 6 plus 2 is 8, so we have the absolute value of 8 here, plus 3. And the absolute value of 8 is just 8. So we have h of 6 here is equal to 8. We bring down that 3. And so now we have 8 plus 3, which comes out to be 11. So we have h of 6 here is 11, and that is our final answer. H of 6 is 11. G of a is equal to 3 to the 3a minus 2 power, and we had to find g of 1. All right. Well, since we're given our function and that we are asked to find g of 1, I'm going to rewrite this, my function, but instead of a, I'm going to put a 1. So every single time I have an a, I'm substituting with a 1 to find when 1 is plugged in for a. So g of 1 is equal to 3 to the 3rd power times 1 minus 2. Okay? So now let's just simplify that. Bring down the g of 1 again is equal to, well, we simplified the exponent first, right? Everything that's going up there. So 3 times 1 is just a 3. So we have 3 to the 3rd power minus 2. And then 3 minus 2, we can subtract to be 1, so we have g of 1 is just 3 to the 3 minus 2 power, which is a 1. And we all know what 3 to the 1st power is. G of 1 is equal to just 3. And so our final answer here is g of 1 is equal to 3. W of t is equal to negative 2t plus 1. And we have to find w of negative 7. All right. Well, so I'm given my wt, and I need to find w of negative 7. Every single time I see a t, I need to put in a negative 7. So w of negative 7, what we're trying to find here, is equal to negative 2 times a negative 7, and then plus 1. So now let's just simplify that. W of negative 7 comes down. Negative 2 times negative 7 is a positive 14. Remember, a negative times a positive is a negative. Negative times a negative is a positive, but a negative times a positive is a negative. So we have w of negative 7 equals 14 plus 1. 14 plus 1 is 15, so w of negative 7 is equal to 15. And that's it. Our final answer. G of x is equal to 3x minus 3. And we need to find g of negative 6. All right. Well, what I want to do is every single time I see an x, I'm going to plug in a negative 6. That's what that's asking me. So g of negative 6 here is equal to 3 times the negative 6 minus 3. So now it's just time to simplify. G of negative 6 comes down. 3 times negative 6 is a negative 18. We have a minus 3. So then g of negative 6 here is equal to, well, negative 18 minus 3 is a negative 21. So we have negative 21 right there. So our final answer here is just g of negative 6 is equal to a negative 21. H of n is equal to negative 2n squared plus 4. We need to find h of 4. Okay. So now we need to find h of 4. So every single time I see a n, I'm going to substitute a 4. So when I'm finding h of 4, that's meaning. So negative 2 times 4 to the second power plus 4. So let's just simplify. H of 4 comes down. Negative 2 stays out front because we have to do our exponent first. 4 to the second power is a 16. So we have negative 2 times 16 plus 4. Negative 2 times 16 is next here, so we have h of 4 equals negative 2 times 16 is a negative 32. And then we have a add 4 there, or plus 4 there. So we then have to combine negative 32 and 4, which comes out to be h of 4 is equal to a negative 28. And so our final answer here is just h of 4 is equal to a negative 28. H of t is equal to negative 2 times 5 to the negative t power minus 1. And we need to find h of negative 2. All right. Well, what I'm going to do is every single time I see a t, I'm plugging in a negative 2. That's what the h of negative 2 is meaning. We're finding when our function, when t is equal to negative 2, what is h of negative 2? So h of negative 2 is equal to, let's plug in negative 2 in for every t. Negative 2 times 5. Now here's tricky, or here's where it's tricky. The negative's out there for the t, but our t value is a negative 2. We subtract a 1. So let's simplify this now. H of negative 2 here, negative 2 just up front, times 5 to the, well, negative times the negative is a positive. So we have a positive 2 minus 1. Now, simplify the next step again. H of negative 2, negative 2 times 5 to the 2 minus 1 power is just a 1. Alright? So we know 5 to the first power is also just 5, so we can multiply the negative 2 times 5. So we have h of negative 2 is equal to negative 2 times 5, which is a negative 10. And so our final answer here is just h of negative 2 is equal to a negative 10. F of x is equal to x squared minus 3x. And we need to find f of negative 8. Alright, well, what I want to do is every single time I see an x, I'm going to plug in a negative 8. So, f of negative 8 right here is equal to negative 8 squared minus 3 times a negative 8. So we have two x's that we need to plug in a negative 8 for. Now it's time to simplify. So, bring down the f of negative 8 right here is equal to negative 8 squared is a positive 64. Negative 8 times a negative 8 is a positive 64. So we have positive 64 right here. And then we have a minus 3 really times negative 8, which is a positive 24. So this minus 3 times a negative 8 is like a plus 24. So now we have 64 plus 24 we can add together. So let's bring down the f of negative 8 here. And 64 plus 24 is an 88. So our final answer here is just f of negative 8 is equal to a positive 88. P of a is equal to negative 4 to the 3a power. And we want to find p of negative 1. We're going to find p of negative 1. Well, every single time I see an a, I need to plug in a negative 1. So we have p of negative 1 right here is equal to negative 4 times 3 to the negative 1 power. Okay, or 4 to the power of 3 times negative 1, better way of saying it. So now let's simplify that. 3 times negative 1 is a negative 3. So we have p negative 1, and we need to deal with the exponent first. Negative 4 times a negative 3 up there. Okay, so now here's where it gets tricky. Okay, we know a negative 3 exponent can rearrange this. We want to keep it as a positive exponent. So we have p of negative 1. It's the same thing as the negative that's out here. We're going to leave it up top, negative 1 over 4 to the positive third power. And what that allows me to do, so again, let's see that actually. Negative 4 to the negative third power, the same thing as negative 1 over 4 to the positive third power. And then negative 1 can be like out front too, it really doesn't matter here. But anyway, simplify that. P of negative 1 is equal to, this with a negative out front, 1 over, now 4 to the third power. Okay, what's 4 to the third power? Well, 4 to the third power is 4 times 4 is 16, and 16 times 4 is 64. So it's 64 right there. So our final answer here is just p of negative 1 is equal to negative 1 over 64. P of t is equal to 4t minus 5. And we want to find p of t minus 2. Okay? So what that means is every single time we see a t, we need to plug in a t minus 2. Now this can get a little confusing, right? So pay attention carefully here. So p of t minus 2, plug in that in for t. We have 4 times, now we're plugging in, that's a t, plug in t minus 2. Minus 5 there, okay. So now we need to simplify. So we bring down p of t minus 2. We need to distribute this 4 across. 4 times t is 4t. 4 times a negative, or minus 2 is a minus 8. And now we have a minus 5 that comes down. Now we need to simplify. We need to combine our like terms. So p of t minus 2 here is equal to 4t. And then we have minus 8 minus 5. Minus 8 minus 5 is a minus 13. So our final answer here is just p of t minus 2 is equal to 4t minus 13. G of a is equal to 4a. And we want to find g of 2a. Alright, this gets a little confusing here, so let's take our time. Every single time we see an a, we need to plug in a 2a. So g of 2a is equal to 4 times, here's my a, and I'm going to plug in 2a for it, 2a. Okay? So now we just need to simplify. So g of 2a is equal to 4 times 2a is just 8a. That's it. Our final answer is g of 2a is equal to 8a. W of n is equal to 4n plus 2. And we want to find W of 3n. Okay? Well, every single time I see n, I need to plug in a 3n. So when I find W of 3n, that is what I'm doing. So I have 4 now times, be careful, for the n, I'm plugging in a 3n. 3n plus 2. And now I need to simplify. Alright, so we have W of 3n right here is equal to 4 times 3n is a 12n. We bring down the plus 2, and that's it. There's nothing more we can simplify. So our final answer here is just W of 3n is equal to 12n plus 2. W of a is equal to a plus 3, and we need to find W of a plus 4. Okay, be careful here. We have a plus 3 and a plus 4. What this means is every single time we see an a, we need to plug in an a plus 4. So the W comes down, so W, instead of a, we have W of a plus 4. So that's equal to this a here. Let's plug in an a plus 4 for it. So a plus 4 in space with that a, and then we add a 3. So now let's just simplify. And it's pretty quick and easy now. The 4 can't combine with an a, but we can combine it with a 3. So w of a plus 4 here is equal to a plus 4 plus 3, which is 7, and that is our final answer. H of x is equal to 4x minus 2. And we needed to find h of x plus 2. All right. So what that means is that every single time we see an x, we need to plug in an x plus 2. So we have h now of x plus 2 here. And that's going to be equal to, well, 4 times x plus 2. So we're plugging in for that x plus 2, and then minus 2 on the outside. Well, what we need to do now is just simplify. So h of x plus 2 just comes down. We distribute the 4. 4 times x is 4x, and 4 times 2 is 8. So we have 4x plus 8 here, and then we have a minus 2 on the outside. So now it's time to simplify a little more, one last little step. 4x can't combine with anything, but the 8 minus 2 can. So we have h of x plus 2 here is equal to 4x. Now 8 minus 2 is a 6, so we have plus 6, and that is our final answer. K of a is equal to negative 4 to the 3a plus 2 power. And we want to find k of a minus 2. So every single time we see an a, we need to plug in an a minus 2. So we have k here of a minus 2 is equal to negative 4 to the 3 times a minus 2 power. Remember that a, we plug in an a minus 2, then we have plus 2. So this one gets a little tricky, because all really what's happening is going to be in that exponent, right? So we have k now of a minus 2, so bring that down. We have minus 4 to the power, we need to distribute this 3. So 3 times a is a 3a, and 3 times a minus 2 is a minus 6. And then we have a plus 2 over here. So now we need to simplify that exponent a little more, combine the negative 6 and the positive 2. So we have k of a minus 2 is equal to negative 4 to the power of 3a, and then minus 6 plus 2 is a minus 4. And so at this point, we have a negative 4 to the 3a minus 4 power. There's really nothing we can do. We can't take 4 to that power because we don't know what the variable a is. And so our final answer here is written as is. K of a minus 2 is equal to negative 4 to the power of 3a minus 4. G of n is equal to n to the third minus 5n squared. And we need to find g of negative 4n. So every single time we see an n, we need to plug in a negative 4n. So g here of negative 4n is equal to that n right there. So we have negative 4n right there to the third power minus 5 times negative 4n to the second power. All right. So now we need to simplify this. Okay. Well, g of negative 4n, we just rewrite that down here, is equal to. So we have negative 4n to the third power. Well, what we need to do is, okay, negative 4 to the third power is a negative 64. Right? Negative 4 times negative 4 is a positive 16, and positive 16 times negative 4 is a negative 64. And the third power also goes down to the n, so we have n to the third power right there. So now we have subtracting by 5 times, okay, negative 4 into the second power. Well, negative 4 times 4, negative 4 times negative 4 is a positive 16. And we have n squared, or n times n is n squared. So now we need to simplify this a little more. We still can distribute that 5 across. So we have g here of negative 4n. We bring down the negative 64 n to the third power. And then we have the minus. Well, 5 times 16 is 80. So we have 80 here, n squared. And so our final answer here, there's nothing more that we can combine. There's no like terms. Is g of negative 4n is equal to a negative 64 n to the third minus 80n squared. F of n is equal to n squared minus 2n. And we need to find f of n squared. So what that means is every single time we see an n, we need to plug in an n squared. So f of n squared is equal to, now this gets tricky here, n squared, we're plugging in for n, all to the second power, minus 2 times n squared. Okay? Well, if we have, now when we're simplifying this, an exponent, all that to the exponent power, we multiply the exponents. So we have f of n squared equals, right, 2 times 2 is 4, so we have n to the 4th power here, minus, and we distribute now, or not distribute, multiply negative 2 times n squared, which is just negative 2n squared. And since we have no like term that we can combine, this is our final answer. F of n squared is equal to n to the 4th minus 2n squared. P of a is equal to a to the 3rd minus 5. And we want to find p of x minus 4. Well, since we want to find p of x minus 4, we need to substitute every single x minus 4 for every single a. So we have p of x minus 4 here is equal to x minus 4 to the 3rd power minus 5. So what I need to do now is simplify this. And since I have x minus 4 to the 3rd power, I need to write this as x minus 4 times x minus 4 times x minus 4. So we have p of x minus 4 here is equal to x minus 4 times x minus 4 times x minus 4 minus 5. So now what I'm going to do is just distribute the first two together, really x minus 4 all squared. What is that? So we have p of x minus 4 here is equal to, as from our FOILs, so the same thing, x times x is x squared. X times a minus 4 is a minus 4x. Minus 4 times x is a minus 4x as well. And minus 4 times a minus 4 here is a positive 16. And that's going to be all multiplied by x minus 4 eventually, and then we have minus 5 sitting there on the way. Well, we can simplify this. Well, I like to do that. Minus 4x is a minus 8x. So we have p of x minus 4 here is equal to x squared minus 8x plus 16. And we're timesing that by x minus 4, and then we have minus 5 up there again. So now all parts of my first parenthesis are multiplied by all parts of my second parenthesis. So p of x minus 4 here is equal to, and it's kind of hard to show the arcs, but it might get a little confusing. X squared times x is x to the 3rd. X squared times a minus 4 is a minus 4x squared. So now we deal with the 8x, or minus 8x. Minus 8x times x is a minus 8x squared. Okay? Then we have the minus 8x times the 4, minus 4, so it's a positive. Negative times a negative is a positive. That's a positive 32x. So now we have the 16, okay? So we multiply 16 times the x here is a 16x. And 16 times the minus 4 is a minus 64. Okay, 16 times minus 4 is minus 64. We then bring down the minus 5. So at this point, we need to simplify by combining our like terms. So we have p of x minus 4 here is equal to x to the 3rd minus, now we combine here, minus 4x squared and a minus 8x squared is a minus 12x squared. Okay, then we combine our like terms of the x's. Okay, 32x plus 16x is a 48, positive 48x. And then we have minus 64 minus 5 is a minus 69. So again, our final answer now here, can't simplify anymore, it's p of x minus 4 is equal to x to the 3rd minus 12x squared plus 48x minus 69. Okay, so let's double check that, make sure I'm good. And yes, we are. h of t is equal to 2 times 3 to the t plus 3 power, right? And we want to find h of 4 plus t. Okay, so what I want to do is every single time I see a t, I'm going to plug in a 4 plus t. So we have h of, and be careful with the plus signs in the t, okay? H of 4 plus t, that's why t's a little curly there, is equal to 2 times 3 to the 4 plus t exponent plus 3. Okay? Well, this one's actually fairly simple. We have to deal with the exponent first, so let's simplify that. 4 plus t, I cannot combine together, but I can combine the 3 and the 4 together. So we have h of 4 plus t here is equal to 2 times 3 to the 4 plus 3 is 7, so it's 7 plus t power. Well, at this point, there's really nothing else we can do to simplify. We can't take the exponent of 3 to that power because we don't know what t is, and the 2 just kind of stays out front. So our final answer is already written now as h of 4 plus t is equal to 2 times 3 to the 7 plus t power.
Minute Math. When you need help, you use Minute Math. Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.